Hi Mark, so my research thesis is improving Sydney's urban transportation with the integration of rideshares and train system. Before moving on to my topic, these are the project requirements that have been taken into consideration when doing my research. Based on my literature review findings, it was found that many countries have used rideshares as a transportation system to reduce car ownership, traffic congestion, and air pollution, which is a problem in Sydney. Researchers also mentioned that integrating ride sharing with the transport mode would be an even better solution to solve transportation issues, especially in areas with poor transportation like the suburban areas in Sydney, for example, Liverpool and Campbelltown, which is what I'll be focusing on. Seamless integration of ride sharing and train advantages is that it offers fast, reliable, and affordable transfers to and from transit stations to enhance the urban mobility of the residents. It's safe as the car journey is being tracked and commuters are able to see it from their phone. It reduced transportation costs as the full price is being split among the number of occupants. It is convenient as it can be booked from a smartphone app whenever needed. Reduces carbon emissions as there is a high number of occupant in a single vehicle per trip. It is accessible as the car will pick up the commuter nearby their area and is also applicable to all ages. However, the weaknesses is that it is difficult to encourage commuter who already owns a private vehicle. It can be expensive if used for a long distance trips, which is why I would like to constrain rideshare journey only to the nearby transportation system or any other transport mode. How I came by this strategy is that from figure 1 it shows the Sydney CBD 2 kilometers catchment radius, and figure 2 shows the catchment radius of the surrounding suburbs close to the CBD. We can see that there are at least 5 train stations available around 2 kilometer radius, which shows that transportation isn't an issue there as it is accessible. However, if you look at the suburban areas like the Campbelltown and Liverpool, which the 2 kilometers radius is shown in the figure 3 and figure 4 respectively, there's only one transportation available, which is one train station. This shows that residents living in the area have very limited transportation available, which is why I would like to focus on my research on these areas, as in order to have an integrated transportation system, all areas in Sydney have to be focused. And this is why what I would like to do in my future works is to implement a concept design of rideshare train system to find out the effective and accessible meeting points, to conduct a survey for feedback and validations, to encourage the use of rideshares to travel to the nearest train station, to investigate the benefits of car sharing, determine the social, environmental, and economic impact of the solution, and lastly, estimate CO2 emissions as per required in the CIP of this thesis. Thank you. That will be all.
My topic is going to be integrating low carbon emitting transport. So what I've found out about the CIOP so far is the 3 key points of convenience, accessibility, and reliability from the literature review. And these key points is why transport works and why users use the mode of transport that they like. There is another topic of frequency that they do discuss in terms of transportation. However, from the literature review, it was seen that frequency was not a long-term sustainable approach, which would not be relevant for the CIOP. In terms of the knowledge that was acquired for the background knowledge as to why integration is important, we look at Sydney's Opal card in terms of transport integration, which has decreased travelling times by about 10 minutes per trip. And that's really important because if you increase transport integration, it means it becomes more convenient and accessible for commuters in Sydney. So the solution that I've taken so far is creating a short distance, long distance approach. So it's short distance flexibility with long distance accessibility, which covers the key point of convenience, accessibility, and reliability. It takes bicycles as the short distance approach and takes trains with long distance accessibility for commuters. And what this tries to do is it integrates bicycle networks with train networks and tries to create a long-term sustainable solution. Now, the strengths of this solution is, number 1, you're not relying on private motor vehicles. Number 2, when renewable energy becomes more sustainable, trains will become a form of low carbon emitting transport, and bicycles are already a low form of carbon emitting transport. So this can be sustainable for the future. The weaknesses of this project of this solution would be, number 1, land usage is going to be a problem because you have to integrate it with the land. Number 2, it's going to take time to integrate this with societal norms and the city of Sydney itself. and that's going to be some of the weaknesses. Now, my plan for progressing through this project is, number one, I'm going to need to do a preliminary design of the cycling routes, which will involve Parramatta, Stratfield, Liverpool. Also, I need to conduct surveys to estimate how many people will be using this cycling route and cycling train integration. And those will be things that I need to progress for in the future of this project. Now, any delays that can occur would be during the experiment section, which would include delays in getting the data and delays in designing the work. So the delays in getting the data would mean I have to get enough data to make sure that the research is valid, and delays in design would be just making sure enough time to design a proper system that would be fit for the City of Sydney. And that is why integrating low carbon emitting transport. Thank you.
Hi, I'm Raymond, and my topic is to improve traffic flow with the influence of electronic road pricing. From my literature review, I found that there were 4 main causes of road congestion. These were a high volume of privately owned vehicles on the road, recurrent travel patterns resulting in peak hour traffic, a low use of public transport, and a low supply of parking spaces resulting in mindless driving in urban areas. Considering that there are many solutions that could relieve congestion, electronic road pricing addressed all 4 causes. Sydney currently only has tolls on major motorways. They are run by third-party organisations through commercialised agreements individually. This combined with a fixed price rate equates to inefficient management of congestion. My solution to congestion on major motorways is to introduce variable pricing and integration between all toll networks. Congestion in the city can be resolved by introducing cordon tolling, where people are tolled for driving into the city. Both these solutions, however, are restricted by public backlash. In order to come through with these solutions, public acceptance must be reached. My goal is to see if increasing awareness can increase public acceptance, with the points as shown. A summary of my future work would require me to produce surveys and gather data from the public, consider other project obstacles such as backlash from commercialized agreements, a pollution study, a cost analysis of construction, and overall societal impact of these solutions.
Hi everyone, my name is Tony, and my focus in this transportation research is finding ways to reduce congestion in Sydney. My primary aim is to look at car sharing and its feasibility in Sydney to provide an intermediate solution between private transport and public transport. In addition to this, I will delve into existing solutions that are being widely used around the world, namely integrated transport hubs. Integrated transport hubs have been, in recent years, the main solution to increasing the efficiencies of existing transport infrastructure. It achieves this by intertwining different systems together to work in tandem. This translates into decreased waiting time for commuters, decrease in energy usage, decrease in running costs, and as well as increasing overall productivity. Because of the uniqueness of Sydney's geography, it is infeasible to follow other global cities in creating mega hubs. Rather, Sydney should focus on smaller hubs scattered around to cater for its widespread population. The first few hubs should be situated in the more densely populated cities such as the Sydney CBD, Parramatta, and Liverpool, which conveniently also has existing infrastructure that could be built upon. A 5-kilometre catchment radius provides a good insight of these areas that could be serviced by these hubs, as in peak hour, the slowest areas have an average car speed of 15 kilometres an hour, meaning that in the worst of times and places, people could get there still within 30 minutes. The second phase can then be focused on suburbs that are in between these cities to increase the serviceable area for those in between. Overlapping of the radius for now is avoided to be able to access more people. As the project progresses, more smaller hubs could have an overlapping catchment to increase adoption by adhering to the 30-minute commute to work ideology. The focus now shifts on getting access to these hubs. So we've been looking at car sharing, as it has been becoming a popular alternative to private car use, and mainly attracts those in dense areas that do not have space to own a car. We can further increase the convenience for commuters by integrating the existing Opal payment system into the car sharing network. It has several benefits, such as having less need for large car parks, as less cars are needed to service the same number of people if they were using private cars. It increases vehicle utilization and decreases carbon emissions, given that the right vehicle is chosen. However, the growth in car sharing has slowed down in recent years, and we aim to incentivize the use of car sharing by pairing it with transport hubs, reducing the private car use, which then in turn reduces congestion and carbon emissions. To be able to reach our goals, we are focusing on reaching out to the market via surveys to assess their sentiment on changing to such a vastly different system, especially those that have already committed a lot of money into their private cars. This will be achieved through closed-ended questions to give a snapshot of a large sample size, clustered sampling for a bias towards those that commute to work, and using face-to-face and online surveys so that we get a larger variety of people. There are drawbacks of surveys, however, as they do bias towards certain demographics, such as those that are compliant to completing surveys. However, it should provide us with ample initial data to base our next steps moving forward.
Hi, my name is Azwan, and my research question is how to reduce road congestion and use of private vehicle in Sydney developed area. So the aim is to find possible method to improve different modes of transportation, and the outcome is to propose a methodology in order to design, explain, justify, and present my own solution to this engineering challenge. And the background is the idea I get is from the congestion problem in Sri Lanka, which the author proposed that the quantity and quality of public transport are needed instead of adding number of transport. And then the problems relating to the current rideshare system, which different company target to remove privacy issue among the passengers. And then the proposed solution is the first one. I propose to design the light rail vehicle to carry bicycle without disturbing the passenger's capacity, so I can create a hook at the outer part of the light rail vehicle. And the second solution is to create a curtain-like design which can be implemented into the interior design of the car. And then this is the picture from the San Jose, California bus, which the hooks can carry bicycles. And the proposed methodology is basically from designing the model using engineering software like SolidWorks, and I have to find appropriate size, dimension standards that can be used to design a proper model, and to conduct a well-organized survey to know about people's opinion on my idea. And the strength is because bicycle might be restricted to be in Sydney light rail if the transport is crowded, so I can create designs that will not affect the people on board, and provide optimal privacy for passengers while ride sharing by provide gap between passengers while carpooling. And then the weakness is difficulty to find the appropriate way to propose designs such as dimension, size, and standards. And possible delays is because the computer crash and the late receipt of results. My future work is based on my solutions that I propose. I will do CAD modeling, likely by using the software. And the second one is conducting a complete survey to know people's opinion about my idea in the future. So that's all from me. Thank you.
So for my chapter, I'm looking into the application of meta-heuristic methods and multi-objective algorithm in public transportation. There's like several urban transportation network design problem that has been proposed. So, but the thing that we want to look into is the frequency problem. So how one of the ways that we can solve it by using a multi-objective algorithm, which is a method of optimization, and it has been demonstrated in a few studies to be able to solve train scheduling problem as well. The second one is meta-heuristic method, which is a sub-branch of AI basically, and then it has two major components, which is the selection of the best component and the randomization of it. So one of the methods is genetic algorithm, which has shown to be able to minimize bus transfer time, and also taking into consideration the randomness of bus arrivals into consideration. The second meta-heuristic method we want to look at is B colony algorithm, which is can be performed better than GA, which I just mentioned just now, and it has been able to achieve a better solution as compared to initial solution based on the GA works. So for my future plan is basically just to implement the fuzzy multi-objective algorithm in Sydney and analyze the suitability in solving train scheduling problem. And the second one is testing out BA colony algorithm or BCO and implement it in Sydney transportation for optimization and travel time, as well as including intermodal transportation system. That's all for me. Thanks.